Hello everyone, this is Priyanshu Gupta here. So before we actually understand the concept and code the problem, let's first try to understand what the problem is through an example, okay? So suppose let's say there is a user A and there is user B. So now this user has a bank account in which he has 500 rupees balance, and B also has a bank account in which he has 300 rupees as balance. Now A user wants to transfer some funds to B's account. So it's a kind of a transfer, and he wants to transfer 100 rupees, let's say. Okay. So in order to make this transfer, user A used bank's mobile app, and for making this transfer, he basically clicks on the transfer button and provide the details like the amount and the user who he wants to transfer. So after providing those details, the mobile app will hit the API to the bank server basically, and this is a bank server, and A will make basically a transfer request which will be available at transfer endpoint, which will be a post request, and he will pass certain parameters in the request body, and then bank server will interpret this request and perform all the database operations and any other operations that it wants to in order to make this transfer successful. Now first let's see what all operations will be performed by this bank server behind the scenes, right? So first step will be check the funds in user A account, whether he has enough funds to whether he has enough balance in his account to transfer the amount that he has requested for. Then second step will be to create a transfer instance in DB. Okay. So basically bank server will have a database in which it will store all the details, and suppose let's say this DB has two tables. One is user account, which will have all the information about user account funds, like how much balance he holds in account in bank, and second table will be transfer, which will have all the transfer transaction history, and third step will be to deduct the funds from user A account, and fourth step will be to add the funds to user B account. So these are four operations that bank server will perform behind the scenes. So let's first code this part. Let's move to our VS Code. So this is basically a view that I have created this, and in this I have inherited generic API view of Django REST framework. So I am considering that you must be knowing about how to create a basic endpoint and how the views work in Django. And also I have created two tables using Django models. So there are two models, one is user account and one is transfer model. Inside this user account we have a user field, which is a one-to-one field, and balance to basically store how much balance user holds in the bank. And then there is also one more table, that is transfer table, to basically store all the transfer transactions. This has field like initiated by the person who will initiate the transfer, and this transfer to basically who will receive that transfer amount, and then amount which user will specify while making a transfer request. All right. Now in views, let's try to code those four operations. So first thing that we will do is also we will have to add certain permissions here. We will have to check whether user is authenticated or not. So is authenticated, We will have to import this permission. Is authenticated. After checking that, we can proceed further. Now what we will do is we will try to parse the request body. Okay, so request data, and inside this request we will be receiving certain parameters from the user. So we will be getting amount, and this will be request data dot get. And of course you can basically validate the request body using serializer, but I'm not doing that because our goal is to understand how to ensure ACID properties in SQL database and understand about Django transactions. So let's focus on this thing here, amount, and then user will also pass one more parameter that will be receiving user ID. User ID who he wants to make a transfer to. So request data dot get receiving user ID. After getting these parameters, we will check whether user A has enough funds or not. So for doing that, what we will do is we will first get the account initiator account DB instance from database. For doing that, we will make a database operation here using user account dot objects dot filter, and user equals to request dot user dot first. After getting that account from DB, we will see how much funds he has. So if initiator account dot balance, because we have a field balance inside this user account model, dot balance is less than amount which he wants to transfer, we will return an error response. We will have to import this response object from REST framework. Response, and you can say that the status of this response is error, and you can write a custom message that you do not have enough funds, and then in payload there is no need to mention anything right now, and you can basically say status equals to, and you will have to import the status object also from REST framework. From REST framework, import status. Status dot http bad request. After checking this, we will have to basically create a transfer instance. So transfer equals to transfer dot objects dot create, and then we will mention trans initiator initiated by, because we have a field called as initiated by, and then request dot user transfer to. For getting that user also, what we can do is, if it's directly a receiving user ID, right, we can directly add the here receiving user ID, or what you can do is you can fetch the database record and then put the value here, like put that object completely here, but that will involve one more DB operation. So that's why, since I am getting the ID directly, and of course when we link two models, they are linked using the primary key. So in Django we can directly provide the primary key itself. So transfer to ID equals to receiving user ID, and then amount. Amount is basically a decimal field that we have taken here. After creating a transfer instance, what we will do is we will deduct the balance from the user A's account, basically the one who is initiating the transfer. So in order to do that, we will do initiator account dot balance equals to initiator account dot balance minus amount. And since we are storing this balance as a decimal field, what we can do is we can convert this into decimal before performing the operations, right? So for this, we will have to import from decimal, import decimal. After this, we will have to add the funds to whom the initiator is transferring the amount to. So for that, we will have to first fetch the user B's account. So for doing that, receiving user account dot objects dot filter user ID equals to receiving user ID dot first. After this, receiving user ID dot balance plus amount. And also we will have to save these things, right? So initiator account dot save and then receiving user account dot save. Only after using this save function, these changes will reflect in actual DB. So after this, what we can do is return a successful response. Successfully transferred. And payload. In payload also you can pass all the parameters if you want, or I am leaving it blank right now. All right. Now what we will do is we will make a urls.py file. Inside this URLs, I will add basically the paths. And here I will basically make a transfer endpoint from dot views import transfer view transfer view dot as view and name equals to transfer. And in projects urls.py, I will also add the path of this app, that is main app. I'm basically directly forwarding the request to the app URLs. So include and here I will provide the app name, that is main app in our case. Control save. Now I will basically migrate all the changes, and if there are no changes at all, because we had already made the migration file here, then we will migrate. Now before we actually hit the API, let's first create the user records using Python manage.py create user. Let's create super users right now because that doesn't make any difference. So one, let's make it A, email address a@gmail.com, password will be 1234, and we will create a second user also as a super user right now because it doesn't make any difference right now. b@gmail.com 1234 1234 and it's done. Now we will also have to create user account. So for that we will have to go into shell. Right now I am using the default user model that is provided by Django. And I will fetch the A user. And we have got the A, and now fetch the user B. We've got the B. Now let's create the account for them, and we will first have to import user account model. Account A dot objects dot create user equals to A, and balance I'm putting right now as 500, and account B user account dot objects dot create user equals to B and balance equals to 300. Done. Now in order to, since I am using a JWT token authentication mechanism right now here, so we will also have to fetch the token for user A in order to authenticate that user, right? So right now I'm creating those tokens from shell itself. Refresh token for user A, and then we will generate access token. So let's print that. And str access, we have got the access token here. Now we will use this token to provide in headers of request body so that we can authenticate that user. And now we will basically use postman in order to hit this API. Now inside this we will create one new request for transfer, and we will be using post request here, and our server will be accessible at 127.0.0.1 at localhost, basically at 8000 port, and we will hit the transfer endpoint. And in headers we will provide the authorization, and the value will be this, and in body we will provide the raw parameters in JSON. And what we require, basically we will require amount, and amount we will put as 100, and then we will also provide the receiving user ID, and that will be 2 in our case. All right, and then before this, let's start our server. Successfully transferred. Now in case we want to check whether it actually happened or not, what we will do is we will first import transfer and table, transfer model, basically transfer dot objects dot first, and then t dot underscore dect. And yes, it got successfully created here. If you see it, initiated by and transfer to. And in case you want to check the user funds balance, that also you can do. So you can do that here. So now let's again fetch the user account. and then account A dot underscore date, and you can see that the balance is 400. That is perfectly fine. And if you see B, account B funds will be also 400 because the 100 got transferred to user B account. So our code is working perfectly fine. But now there are certain more edge cases here that we will have to cover. So let's discuss about that. How will we ensure that all these operations doesn't lead to any database inconsistency? Okay, so let's try to look into that. So you have seen that we have already performed these 4 operations. But what if suppose let's say we have executed these operations till here, till step 3, and then the server crash. So we have already performed these database operations. We have successfully already created the transfer record in database, and we have also removed the funds from user A account. But till now we have not added the funds to user B account, but the server crashed in between. So these database operations would have successfully executed, but this DB operation was not executed. So this is kind of a problematic situation, and this server crash can happen due to any reason, because of server overload, or maybe due to some unexpected exception raised, or anything which is not controllable, right, which is not in our hands. So how will we solve this problem? And so the problem basically is we have to make sure that all these 4 operations should go through, or nothing should go through, right? If we have started, we should end at here, or even in case we have executed till here and then the server crashes, then we should have some way or mechanism so that we can roll back to the original state in order to prevent any database inconsistency. And this is something called as atomicity. When we talk about ACID properties of SQL database, because ACID properties is something which is only provided by SQL databases, and A in this ACID stands for atomic, and that is what we have to ensure here. We have to package all these database operations in such a way that they all should go through, or nothing should go through. So what we will do is we will create a database transaction and make all these 4 operations atomic. Okay, so let's code that. And that is what I have added in this comment as well. So for doing that, we will have to import transaction, and if you notice here, the first operation that we have performed here that actually has to be performed, that is starting here, right, because here we are checking the funds. So here we will have to start the transaction with transaction.atomic, and then we will basically shift this inside this transaction, basically atomic transaction block. Now whole this code is inside a transaction atomic, basically an atomic transaction block. Now what will happen is, if anything happens in between, then this will roll back to the initial state. So suppose let's say if any exception is raised here, suppose let's say raise exception, then even if transfer object is created, then also in case of this exception, this transfer object will not actually be reflected inside the DB actually, because till we have not executed this transaction block completely, till that point of time, nothing will be committed to DB. Okay, it will be stored in memory, but which is a temporary storage, but all these changes that we are performing inside this transaction block, these changes will reflect in actual non-volatile memory, which is permanent storage, only after this whole transaction block has been successfully executed. So the changes will be committed to DB only after this, only after full block has been executed. Okay, so that is the beauty of this transaction block. So this is how we can actually And let me show this also, okay, that if this is working or not. So if we do raise exception here, or even if we raise exception here, basically after this, and press Control Save, then even if you now try to hit this endpoint, we will get some error response. And if you check the DB, now if I try to get user A account, right, and do account a.dict, then you can see that the fund has not been changed. It is still as it is. But in case I remove this raise exception and press Control Save, then let's try to see what will happen. Now if I hit this endpoint again, successfully transferred. And now if I try to fetch again and see the funds, you can see that the funds have been reduced to 300. And even if I try to get all the transfer records, you can see that only there will be 2 records only, because for the second time when we hit the API and raise the exception, then the transfer object would have not been created in DB because the transaction block was not executed fully. So this is how we actually handle atomicity in Django. Now let's move to the second edge case. Okay. Now one thing that we have to ensure that when we make a transfer of 100 rupees from users A wallet to users B wallet, we have to ensure consistency. And that is what C stands in this ACID thing. C means consistency. So in case of transfer, we have to ensure that total funds before should be equal to total funds after. So earlier, when the user has not made the transfer, the total funds were 500 plus 300, that is 800, right? This is user A, this is user B. And after the transfer happened, when he actually transferred the 100 rupees, the final balance was 400 in user A account and 400 in user B account. This is also 800. So we have to ensure that. Okay. But now since we have made 2 transfers, the user A is left with 300 and user B is left with 500, which is also equivalent to 800 rupees. If we check the DB, account A has 300 rupees, and if we get B, user B has 500, which makes a total of 800. So this we have to ensure, and this is called as consistency in ACID properties. Now let's talk about the third one, that is I, which means isolation. Now this is very interesting. How will we isolate this? So let's try to handle one more edge case here. So let's say this is bank server and this is user A who is trying to hit the API from his mobile app, and he is hitting the API of transfer. Now he has, suppose let's say he has opened the app from his browser also and his mobile app also, and he makes a transfer request to user B, and there's also one more user, that is, suppose let's say he has made one more transfer to B here. Okay, and both 100 rupees, and earlier he had 500 rupees and B had 300 rupees in starting. So he hits this transfer endpoint simultaneously, side by side. So these are basically 2 concurrent requests, 2 parallel requests basically. So server can process these requests concurrently as well, because server is having multiple threads through which it can handle multiple requests in a single time. Because when one thread is working in Python, when it's performing IO operation, In the meantime, other thread can work simultaneously, right? So what happened was we had 4 operations here, right? And first operation was to check whether user A has enough funds or not. So suppose, let's say we have made a transaction block here. This is one transaction, and all the changes will be reflected in DB only after these 4 operations have been executed successfully. Now first transfer endpoint will be hit, so first operation will be performed, and of course user will have basically it will check that 100 is less than 500 or not, and that is, so it will be true, it will be executed successfully. And then we will create a transfer endpoint, so that will be done, of course. And now in the meantime itself, one new endpoint is hit by user A, and then again still because since now these changes of for first request has not been saved successfully on a non-volatile memory till now on our actual DB. So when the server will perform operations for this transfer, this will again perform this first operation to check the user funds. So this will still come as 500, not 400, because the changes for the previous request has not been saved successfully till now. Okay, the changes have not been committed to DB till now. So still for this second request also, the funds in user A account will be 500 itself. All right. So again, this condition will be checked that 100 is less than 500 or not. It is. So transfer instance will be created here also. And then basically for first request, third operation will be performed. That is 500 minus 100. And then for second request also, the same thing will be performed. 500 minus 100. That is 400. And here also 400. And it will be saved to DB. Saved to DB. And here also it will be saved to DB. 400 itself. So while saving to DB, still user A has 400 balance. But actually, since he has made 2 transfer requests, the actual fund should here be 300, right? But that didn't happen here because of 2 concurrent requests, right? And they were trying to access the same resource in DB. So this will result in database inconsistency. And now B final balance will be, of course, since we are fetching the record, it can be either 400 or 500 depending on how when this fourth operation is executed, basically when the user B record is fetched from DB. Okay, but because of this we have ended up with a database inconsistency, which is wrong actually. So we should have some locking mechanism here. If server is already processing on one request that is working on this record, so basically it has fetched the user account record, right? User account record, this user account record for A. There should be some lock so that we can lock this record. So in case other parallel request comes to fetch the same record, it should wait or result in error so that it cannot process or work on the same record in DB till it is logged here, till full transaction block is executed successfully. So second request should actually wait for this full transaction to completely execute and then start executing. If this happens, then it will basically happen sequentially. So in this case, first all these 4 operations will be performed for this first transaction, and then this second request can start, and then the server can start processing this second request, because it will wait till the lock is released by first request. Or we can simply say result in error also. So in Django we have 3 kinds of locks. First one is nowait equals to true, which actually means wait equals to false, that it will like basically if second request come and tries to fetch the same record, it will not wait, it will immediately give a error response to the user that right now we can't execute this operation, please try again. Then second one will be nowait equals to false, which means wait equals to true. It means that if second request comes side by side concurrently, then it will wait for the record which is already logged till the lock is released. Okay, it will wait for some duration. It will wait for certain duration, and even in case after that specific duration the lock is not released, then it will result in error. That also you can do, because if you basically if you kept that duration infinite, then it is possible that in some cases this code will keep on waiting infinitely and will never execute, which is also not good. So you should set some default duration which you can set in settings of Django and use that. And third one is basically skip logged equals to true. Inside this, what happens is, if you have used this parameter, what happens is when you will try to fetch the record, if that row is logged, it will not result in error, but it will give you the response from DB which will not have the logged rows. So right now we are fetching only one record, but suppose let's say you are fetching some 50-100 records in a single go, then you might want this feature, like, because you don't want to affect other users, right? So in order to do that, what you can do is, if some rows are logged, don't fetch those records, only fetch those records which are not logged. In this way you will not be affecting other users. Right now what we will do is we will use this nowait equals to true. Basically we will not wait, we will directly give error. For doing that, what we will do is, when we are fetching this user account specifically, we will use dot select for update. This is the lock, and this is the lock which you can only use inside a transaction, because of course if you have not made this transaction, then this will be a kind of an independent operation, independent DB operation, and there it doesn't make any sense to put a lock. So this lock will be valid only till this transaction is executed. Okay, till this transaction is not executed, basically only till that duration this lock will be applied to this row specifically in the DB. And then we can say here no wait equals to true. Basically wait equals to false. So it will not wait, it will give immediate error that this row is logged, so we can't perform this operation right now. And you can catch that exception and give that in the response as well. So this is how you actually handle concurrency, and you have basically isolated this transaction completely so that no database inconsistency happens. So now we have also covered the third property of ACID, that is isolation, and fourth property of ACID is durability, which means that once the transaction is executed successfully, the changes will of course be stored over the non-volatile memory, that is a permanent storage, and changes will reflect pakka. Even in case system fails, then after the transaction is executed, then also the changes will still be there because it has been committed to DB successfully in a non-volatile memory. So that is basically durability. So that's what I wanted to tell you in this video about database transactions and ACID properties. So in this way you can ensure SQL ACID properties in Django using transaction and database locks. And in case you want to know more about Django transactions, then you can of course check out the Django transactions official docs, in which you can learn about nested transaction blocks and how to handle exceptions in transactions. So that is something I want you to learn more in this, beside this. Otherwise, this information is enough for you. So that's it for this session. I will see you in the next video.